to 2025. And at the same time, other side, the population is going up. Now, this is the one of the major challenge how
కూర్చుంటే ఇక్కడ ఆయన ఆన్ చేస్తే డిస్టర్బెన్స్ వస్తుంది. పోయినట్టు ఆయన కనెక్షన్ పోయినట్టు. Hello. Hello.
Continue, sir. Now you are audible.
Okay, okay. Sorry, my line got disconnected, or I don't know.
Screen share, Jane, sir. You share your screen.
Okay, just 1 minute. Let me just do the screen share. Host to disable the participant screen sharing. You need to do participant screen sharing, maybe. I'm not getting access to share my screen. Okay, now I got it. Are you able to see the screen?
Yes, we are able to see it. Please continue.
Yes, sir. Please go ahead. Please go ahead.
Sorry, I hope you have seen the screen earlier.
Yeah. This was over. You can move next slide. Yeah. Further. Yeah, this is the.
Okay, fine. Now, what I was explaining is that demand for the food grains is almost 70% more is required by 2050. Whereas another problem what we have is that 70% of the world's fresh water is going to be used for the irrigation, agriculture. Now, out of the 70%, there is a 40% is only the actual utilization. Now, how to improve the utilization of the water, that water efficiency improvement, and it is the major tool available with us, and we can focus on this water efficiency improvement to overcome the 70% to the future demand. This is only the solution available at this point of time. And Meda Rubicon is the Meda Rubicon joint venture is mainly focusing on the canal automation to improve this particular 40 to 50% the efficiency for the water utilization sector. Now, if you see this screen, India is the largest agriculture bed. It's almost like a 62 million hectares is the agriculture, I would say agriculture space available for our country. Whereas if you see the bottom side, we are the highest loser. In that case, our efficiency of the water utilization, we are also standing in a highest position. That means we are not utilizing properly the water in agriculture sector. Now, to overcome this, and we propose the canal automation solution. Now, the fresh water, as I told you, 70% is going to be used for the agriculture, and second one is only 37% water is used by the real agriculture usage. Remaining 60+% is going waste in today's environment of the irrigation sector, the agriculture sector. Now, how to improve this 37% to maybe 70%? Definitely, our agriculture sector will get a huge amount of water that is going to directly sustainability will increase, profitability will increase, and all our future problems are going to be solved. Now, here the increase of the water availability, there is only one improvement which we can do in the last circle, that is improving the irrigation water use efficiency. That is one we have in our hand today. Remaining like desalination, recycling, and household industrial conservation, which are not effective. But if you increase the efficiency, definitely there's a good effectiveness will increase. Then, if you look at the real losses are concerned, one is the leakages from the canal, seepages, unauthorized use, measurement error, and the leakages around the farm outlets, and evaporation. Evaporation, which is not in our control, leakages well in our control, seepages can be in our control, and the proper distribution is also one of the major objective where we can improve the water distribution efficiency much better than the present scenario. We have done this experiment already in India, and we have shown very good amount of results. And that definitely should go to the national wide now to improve the efficiency of the water utilization. Now you see, I'm talking about the mainly for the canal automation, what it is. Now here, the present scenario, the distribution management, water distribution from the dam to the tail end, manual to automated, and automated to remote monitoring, remote operation, and autonomous. Now the solution, whatever we have provided today, is autonomous control. No need of any manual intervention. Straight away that autonomous control can be implemented with our solution. Now these are all the different levels of the autonomous control, from 1 level to level 5. If the level 5 is achieved, it's really a wonders in the canal automation point of view. And this canal automation will definitely give you a lot of data, lot of the picture of the water distribution and the consumption of the each and every farmer, then each and every outlet. Based on that, lot of improvements can be taken there. The data will provide you a lot of insight. Now, if you see how the autonomous control will work, I will explain you. If you see this particular picture, dam, from the dam, water will be distributed to the main canal and the branch canals, and it will come to the branch canal and it will go to the farming land. If you see here, the autonomous control should happen from the dam gate control to the farming land control. That means the DPO, in our term, it's like a DPO, where in the DPOs, whatever water is consumed from many outlets, the information will continuously pass on to the each cross regulator in a real-time communication mode. In this communication mode, whatever the amount of the water is consumed at the tail end or the farming land, it will go to the next upstream level gate control. In the upstream level also, the gate will automatically get open to discharge that much of water from the upstream to downstream. That means always the canal will be maintained at the defined upstream level in an entire segment of the dam to the tail end. That is the main advantage of the autonomous control, because all these things, all these controls will go like systematic communication network. There is a lot of computer software which is going to handle this all this management and deliver the water from mainstream to up to the farming point. Now that is the autonomous control. Now, if you see this particular one, this is called a cross regulator or the outlet. These gates, like the upstream, you see one cross regulator is there, and this is one more branch output, which is coming here. Now, this particular one, if you see based on the control, both these gates will automatically, continuously in communication mode, and the water discharge management will happen in the systematic process. And the main importance of these things, all these gates, even the CR, head regulator, distributory, lateral or DPO, every gate is operated with a solar panel. That means the amount of energy required to operate the gate is simple 100-watt solar panel. And whatever the stand you are seeing, that is inside, there is a battery. The energy will be stored in a battery, and gate will be communicated. Whatever the top white one you are seeing, that is an antenna that gets the information from server continuously. There is a server control, SCADA control station. From the control station, entire canal will get a continuous communication how to maintain the levels and how much amount of the water to be discharged from one station to other station. Now, this is the canal automation, the picture. And also, if you see here, there is many different types of gates, like a flume gate, or like the slip meter gate, slip gate, and slip meter with a different size, and picometer and a blade meter. Different gates are used for this. Now, if you see one of this particular picture, there is a blue lines are there here. In this blue line is called a ultrasonic sonar sensors. Each gate inside, there are many sensors to measure the flow. In the turbulence flow or whatever the dynamics of the water, the amount of the water is discharged from this gate is going to be measured. And also the flap, whatever you are seeing on the black side, is like an aluminum alloy. It's almost the kind of material used for the aircraft, and which is lightweight, and this is going to operate up and down, and the entire mechanism of this particular motor and all these things will be controlled with a small power available, which is from the solar panel and battery, and entire this gate is operated with a 48-volt supply, which is generated from the solar panel. Now, these are all the gates. And there is a special description on this. Then in the detailed presentation, I can explain you each and every gate, what is the accuracy of the flow measurement, what is the accuracy of the level control, and the kind of materials used, everything we can explain in the detailed presentation. But these are all the gates integrated with the existing canal, whether the canal is lined or not lined. The gate mounting structure should be made properly to install these gates, and it will work. if you see, these are all the sites implemented in other than the India. I will show you some of the sites in India also. But these are all the sites with a different conditions and the cross regulators, distributor outlets, and the DPO outlets. Different pictures we are going to see from here. Then the other one is the dedicated integrated communication infrastructure, because all these gates are going to be synchronized one after the other from the dam gate to the tail end gate. Now all these gates has to be continuous communication. The communication network will be implemented, dedicated network in the field area, because we are not going to depend on the GSM or the regular communication. This is the RF communication, and we will not have any disturbance from the other networks. This dedicated line is required, because if you don't know how the water is flowing, some places overflow, which is going to damage the canal, and which may flood sometimes. That's why this dedicated communication is required. This is the communication interface. This is also in the communication tower also will work with a solar panel. That means no place we have taken the outside power. It's the entire system is works with the solar panel. Now, if you see here how the communication network will be. Now, in this communication network, like each outlet, they talk to each other. That is a peer-to-peer communication, and at the same time, peer to the multi-point communication, and at the time, point-to-point communication. This communication has been designed such a way that to meet all the entire irrigation requirement. This communication has been designed. It is established one is in Kaleswaram and one is in Narayanpur left bank canal. Narayanpur left bank canal, we have implemented almost 15 towers in entire segment of the 1,200 kilometers range. 15 towers we have implemented. Now, if you see that the information point of view, irrigation management software, there is a bit software is required. In this bit software, the irrigation schedule, advisory, water order, that's a portal. That means in future, suppose a farm of 100 acres or someone, if they want to water at so and so time and so many amount of the liters, they can feed from the mobile phone to a server. Automatically, the particular time gate will get open and particular amount of water will be discharged to the particular station. That level of integration is available in this network, entire network. Then the network visualization, network topology modeling, distribution planning, and SCADA connect, remote connect. You can continuously see the data, what is happening, and how the distribution is happening, and how automated delivery is happening. Everything you can visualize from the entire this picture. That is called management software. This software is a very complex software. Today, whatever the gates installed in our the Narayanpur left bank canal, there are 4,230 gates are installed. All 4,230 gates are continuously communicated. They are delivering the water to the farmer. Now, if you see that the kind of display, you can see entire picture of what is happening, how the water dynamics are changing, what time the water delivered, how the levels are increasing, and how this particular data, the entire the water dynamics. That means we can maintain the pool. CR to CR is one pool. In between there are distributaries. If how much amount of the water from upstream CR to downstream CR, and how much is gone to the distributary, and how we can maintain always full supply level, how to maintain that entire picture can be visualized, and you can program and you can use that. This particular site is a Australia site and China. They have implemented very extensively this particular canal automation part, and they have done an excellent job as far as the water the utilization is concerned. Now, in addition to the water rate distribution and other thing, there is a other unknown factor is rainfall. Now, suppose if you maintain a water level at a full supply level, there is a sudden rainfall in that particular area. Then what will happen? The water supply level will increase, full supply level will increase in the canal. During that time, based on the rainfall data and the range in a water level data, automatically that will get open and it will try to protect the canal. It should not be the overflow or something is going to happen, or it's like a floods will get happen. Sometimes automatically the escape gate will be opened to maintain the FSL level always in the safe zone. Now, for that purpose, this weather station is a customized weather station. It will give a lot of information to the server, and we are going to control the water flow dynamics from here. Now, this is the IoT network. This is a different one. Now, these are all the sites with different information in a different other countries like the Chile, the Italy, USA, whatever the dates are implemented, we have placed some of them here. And here, one of the observation you can see whether the canal is lined or unlined, automation can be implemented. The seepage losses we cannot control, but distribution losses and the efficiency improvement can be done. That's why this canal automation, there is no need of always a line canal. The amount of money we are spending for the lining purpose, if you spend some amount of money for canal automation, automatically that efficiency will get improved. This picture will give you that kind of feedback. Other countries, they have implemented automation first before the lining implementation. Now, successful canal automation projects are done in India. India, we have done many projects. I will tell you one by one. This is the project in Karnataka, and I would say in 2019, I think we got the order from Karnataka for Naranpur left bank canal. And this Naranpur left bank canal is almost like a 1,250 kilometers canal with 4 lakh hectares of the agricultural land. They used to have a lot of problems earlier, and the water efficiency is almost like a 30 to 35%. And we have implemented, and we have shown 2022, I think the first full season, 23 is going on, and 21 also we have done some level of the project completion. Now today, last year data, it's always showing 20% improvement in the efficiency, water usage efficiency. The amount of water we used to take earlier from the dam, and now amount of water we are taking now, there's an improvement of 20% is already demonstrated for the country with the canal automation. Now, in this particular canal automation, the main objectives are like the operational efficiency will improve, transparent water supply. Now, today, I'll tell you one of the recent last 1 week what we are doing. There is a shortfall of the water from the Naranpur dam. There is a lot of pressure from the farmers. Now, in the canal SCADA center, the many MLAs and farmers are coming, and they are really seeing whether how much water available, how much distribution is happening, each outlet, how much we are able to deliver, entire picture they are able to see in the my SCADA center in Naranpur. That means a lot of conflicts between the village to village and fighting between the farmer to farmer. You are taking more water, I am taking less water, I am not getting the water. All that, the information is clearly visible, and the Naranpur people are able to manage the crisis situation because the water supply is available, no problem. If the water supply is not available, then only the problems are going to be start. And the visualization picture is really giving a lot of insight to the people there. Now here the project scope is almost like 3,000 kilometers of the canal, 4,203, almost 300 some more dates we have supplied. Supplied out of that. To meet the automation challenges, automated structures like we have created some more new CRs we have designed. We have done the hydraulic analysis of the entire canal, and we have identified some of the locations you need to add some CRs, and those CRs have to be automated. Then only it is possible for the getting the good efficiency. Then based on that, we have supplied a new gates almost 144, and we have constructed almost more than 15 sites, new CR sites we have constructed, and we have improved the water availability efficiency. And all the old cross regulators, like that, these are all the radial gates. All these radial gates, which are not in operation earlier, we have done refurbishment, we have automated the radial gates also. We have not installed the new gates. That means all the automated radial gates have been refabricated, that means reconditioned, and we have installed like an automated motor and actuation mechanism to improve the control of those existing old gates. And we have installed micro weather stations, 60 weather stations, and 15 wireless radio towers we have installed in entire network. And with all these things, there is an improvement in the water efficiency. This is the full project we have done. If you see, this is the network of the entire one, from the dam to the tail end. Tail end goes up to Sholapur, from Karnataka to the Maharashtra edge, and this side entire Bema River. Now earlier, all this automation or the control was not happening. That's why earlier the most of the water is used to be in the Bema River. Now the water we are controlling in the canal itself, we are maintaining the ravine. The Bema River is not getting sufficient water because all the drains used to be connected are connected to the Bema River. Now finally we are able to maintain all the canals, all the channels with a full of water. Now the project planning and the entire that we have formed a JV. We have established a manufacturing plant in Hyderabad to produce around 500 gates per month. Core project management, 50 plus people technical, and the field staff. GIS mapping of the entire canal network. We have done the GIS mapping, and the Karnataka based consultant civil engineers we have used for that. Civil contractors, different teams have worked, warehousing, dedicated the PR team, because the one of the major challenge what we have experienced is whenever we start implement something new, there is a lot of hesitation from the lot of objections from the farmers. We have explained to them, we brought them to the training center, and we have given a sufficient training. We made them understand, and a lot of activity has been done, and a lot of people are working in the project right now. Now you see, earlier this particular site is going to be look like this: the farmer outlet end, there is a distributory, and the solar panel, and entire the gate, the controls are here. It is going to be in fully automation mode. Now, if you see this one, the earlier condition of this outlet is the leftmost picture. Only simple outlet without any control. And farmer used to put a bund because they need to get water. And like this, entire canal has many challenges. Now we have removed all these bunds. We have changed this particular outlet condition to this level, and it's fully operational today and full of water. Always full supply level water we have maintained. Now you see all the like SPC, MBC canal, JBC canal, NLBC canal, you see number of pictures here. All the sites, everything, each and every outlet we have done the work, and we have implemented the automated gates in each and every outlet. Now this was the one of the distributory. The major distributory used to be like this, and there no gate operation and something like this. Then we have removed everything. We have reconstructed the wall because I need a very vertical and the systematic flow. Otherwise, my gate will not move up and down properly. Then after that, we have installed, and it is running smooth with a full of water. Today's scenario, MBC6 D6 distributory. Now this is the MBC, the major distributaries of MBC, the D25 and D26. Now the old gates were like this, metal gates. We have reconstructed civil part of the metal gate, the whatever is required for our gate. We have installed the gate. This gate is each is 1500 mm, 1.5 meter gate. This 1.5 meter gate with trash screen. Trash screen is required. Otherwise, my mouth to the gate outlet will get disturbed. That's why we put the trash screen, and we are able to maintain the flow of water here.
This is your reminder. Take symbol up.
And these are the CRs, that cross regulators which are not in operational condition. We have refurbished all the gates. We have installed the actuation system. Here also you see the right bottom picture, there is a motor with a actuation picture, actuator here. With a solar panel, we are able to operate this hoist, this control. We are able to operate. All the cross regulators with a radio jet we have refurbished like this. Now this is in full operation in the escape jets also. Now these gates, I think for India, this looks like a new gate, and this particular gate is not a vertical shot, it is a overshot gate. And these gates rotate like this to allow the water to flow. It will rotate like this. Now earlier your vertical gate and horizontal gate, it will come up like this, whereas this gate rotates like this, and it will generate. Now what we have done, we have calculated the flow. Other side 2 outlets we have closed, and only with these 3 outlets we are able to get the flow requirement and discharge requirement. And we have installed the flow sensor at the entry path of each canal to measure what is the amount of water inflow and how that inflow water is distributed to each and every outlet. That's why we've installed this flow sensor, open canal flow sensor, flow meters. And here we have done the hydraulic modeling of the canal, and we have suggested where all required additional cross regulator to get the water for some of the distributaries. And after this hydraulic modeling, we have newly constructed cross regulators, and we have implemented in the field in the NLBC. Now you see, this is one of the cross regulator we have designed at the FRS model. We have constructed, then we have installed the gates here. Now even such a big gate, this gate is almost like 3.6 meters height and 2.8 meter width. And this gate simply operates with a small solar panel. It does not need any heavy power supply for this gate. Now this is the dynamics on the same CR, how the water flow is going to happen, how the level is maintained, upstream, downstream, and the flow. Now this is the one more CR we have constructed in IBC. There's a 6 gate CR we have constructed, and we are able to maintain the water in full supply level in entire network, entire canal. Now this is the communication sites, and we have implemented the communication network in entire canal area. From this last point to the first point, it's almost like a 170 kilometers is the IBC canal, and this canal is almost like 80 kilometers, and the SPC, MBC, JBC 50, 80, and 65 kilometers. Entire network and all the 4,200 kilometers, the canals are communicated, gates are connected with this dedicated communication network. And this is the SCADA center we have implemented in Bhimrayangudi, which is the central location of entire this canal network. And in this SCADA center, we have put a training center to train engineers and to train the farmers. And this is the server located with a battery backup, everything. And this server with a redundancy 24/7, 365 days, continuously working with all the gates and the communication network. Now this is the real-time training center we have implemented in all the segments, like including the farmers. We pull them to the SCADA center, and we have explained how the gate works, what kind of challenges, how to improve the water efficiency. And some of the people have given a feedback. We have a toll-free number. Some of the people have replied saying that we got more water, please close the door. And the people used to give us that kind of feedback. And earlier, there's one more example I will tell you. Earlier, let us say 600 mm or 900 mm outlet, they used to get a lot of water because the gates are not in operation. But after we implemented, we have maintained head at full supply level. With openings of 100 or 150 mm, sometimes we are able to meet the supply requirement of that entire outlet, entire the branch canal. That means earlier you imagine 600 mm without a gate, how much water used to flow. Now with after installation of the gate, and the amount of flow required, we are able to meet within 100 or 150 mm opening, even though 900 mm gate or 160, 1.5 meter gate, we are able to meet within 150, 200, 250 mm opening of the gate. That's why you can imagine how much is the waste used to be earlier. Now, this is the early benefits what we are getting, the amount of supply benefits and other thing. And also that 1 hour after implementation of this canal might have constructed almost 15, 20 years back. Last 20 years, they never got any water. The first and most important thing is, entire this network, in IBC, the canal is almost like 175 kilometers. Up to 150 kilometers, they used to get the water. Remaining 20 kilometers, they never get the water. Now, after implementation of the canal automation, in 173 kilometers, we have supplied the water. And all the distributors and outlets, small distributors, up to tail end, we are able to maintain the water. That is the immediate benefit what we have achieved by implementing the canal automation. The only thing is we are able to we are able to maintain the head. Second one is we are able to avoid the unwanted draining of the water from the canal, unwanted distribution. Then automatically water has met all the requirements. Now these are all the serving tailets in the SPC canal. 27 kilometer distributor endpoint the people are getting. And you can't imagine, some of the villages have celebrated the day we have thrown the water. Because their farmers used to depend on the different water sources. Now they really felt very happy. One of the section, the superintendent engineer, who's this man, centerman, he has taken a feedback from the farmers, and he has got excellent feedback from the farmers, and farmers used to cooperate and coordinate with the SCADA center now. They are getting a lot of support. Now, the high level of service by providing the consistent flow to the farmers, we are getting that very good flow here, and always maintained at the full supply level canal. Now, this is the amount of inputs we will get. We can monitor continuously. There is a control engineer sits and monitor entire canal network in a different branches we have done. Now, if you see this one and how that particular operation, you see other side, some people are taking the water and bund and other things. Here you see that there is no bund. Earlier they used to use the bund. After we maintained the confidence to the farmer, we have removed the bund here. That level of the support we are getting from the earlier, they never used to remove this bund after the distributory. Now you see there is no bund, we have removed it. Now you see, sometimes like a canal safety is also one of the important. And we get an alarm extreme events such as high rainflow. Then automatically we have operated some other escape or the other outlets to reduce this flow, the level, canal water level, and we are able to control automatically. Now this is the way the SCADA center, and SCADA center is a 24/7 operation. We are able to monitor all the canals, all the outlets, and we are able to control them. And if it is autonomous, automatically the system itself will control. Sometimes there is a supervisory control will be there to take care of, and field support engineer working with the field team, all the irrigation engineers, and they are getting the good support right now. Now, this is the other project what we have implemented in Telangana. This is in Kaleswaram, Siddipet, that is Ranganayaka Sagar. I think Ranganayaka Sagar, this is right bank or left bank, I don't remember exactly. It's a right bank, I think, the left bank. Now, this particular operation, whatever the gates they were having, and the government has given option for us to implement as a pilot project. We have implemented pilot project. We have installed around 23 gates in this segment. We have installed a server in Siddipet irrigation SC office. From there, they are controlling all the gates. Now, this is the main dam here. From here, water is going, and we have implemented up to this level. This is the main outlets. All these green color are our gates here. And we have implemented, and it is serving almost like the 45,000 acres automated through RD3 distributory network. LMC RD3 distributory we implemented. The one of the important point you see here after the implementation, earlier, whenever they start release the water from the main dam, that is the reservoir, it took almost 96 hours to reach the tail end. Now today, we are able to show the tail end water in 24 hours. That's the beautiness of the automation. That means we maintain all the outlet properly and systematically operate to reach the water to the tail end. That is the first one, and the immediate engineers can immediately take the decision on the water demands. Now, this is the one more project we implemented in Tamil Nadu. It's in almost very old, 2007. We installed a gate in Polachi, I think. This gate is working. This is the head of Rubicon, managing director of the Rubicon, Mr. Bruce. He himself installed and tested and explained to the farmers and irrigation engineers in 2007. And this is the Perambukulam Aliyar project. They have implemented in 2007. And 16 kilometers of the stretch they have operated with a canal automation. Now, this is the factory. This is not factory. This is another project is BPLIS in Karnataka. This is pipeline water distribution network. In this pipeline water distribution network also connected with a SCADA center. This factory is a Hyderabad factory. This BPLS material photo. BPLS also we implemented a very small communication network. This is not 35 meter. Whatever we implemented is 15 meter tower. Because the coverage demand is that much only. Now this is the entire communication network. All the outlets of the pipeline is connected and controlled with this network. Now outlet management system, let's say for every outlet there is a management system which is going to take care of it. We supplied this entire the hardware for that particular BPLS project. Now this is the pipeline connection, pump station control. Pipeline network with the pump station control, we are able to control with our SCADA center. This is the one is a Rubicon, Meda Rubicon factory in Hyderabad, Nacharam. This is in Nacharam, Malapur area. And all 4,200 gates, whatever is required for the Naranpur left bank canal. And we are in the final stage of the getting the order from Naranpur right bank canal also. And for Kalesram, whatever is installed or manufactured in Hyderabad. Now, this is the Rubicon. Our history of the Rubicon is like this. Almost like they have supplied worldwide the canal automation, 35,000 gates they have supplied. Thousands of kilometer canal has been automated. And 70,000 functional points are used already. And they have almost 218 patents. Then 17 countries, the product solutions are implemented. More than 2 billion data points have been processed. And 25 lakh hectares of irrigated land managed with a Rubicon technology. Now the Rubicon is a global company. And we noticed this particular challenges and advantages of this particular one. And Meda worked with Rubicon for Indian operations. And we have taken responsibility and we have implemented this particular project in India. Technologies from them and the entire management and the manufacturing, everything we have automated in India. And this is the Rubicon presence in the worldwide market. Almost like India, Australia, they are very good. Then it's North America, South America, Chile, Italy, then Europe, China also they have. And different countries they have implemented this particular technology. And about Meda, I think the people also not aware of Meda. About Meda, by looking at your this picture, you can understand we are not a civil company. We are not a canal automation company. We are basically a railway company. If you look at in India, more than 60% of the trains runs with our locomotives. We design and manufacture locomotive control and power system. We supply to railways and they manufacture the train. And entire electronics, entire control system, entire motors required for the motor, the locomotives we supply. And whatever the important product in India, what we are seeing today is a Vande Bharat. Vande Bharat is designed 100% by the MEDA. We have a R&D center in Cherlapalli. We have more than 600 engineers working continuously on research and development. This is almost like a 40 years old company, started in 10 by 10 room size. Today we are 4,000 plus people. And we are the largest company in railway segment. And the amount of the confidence and the company development, we started looking how to serve other sectors. And we started working on solar. We have built 1.25 megawatt and 3.85 megawatt solar converter, which is the only product available in the country today. All are China imported. And we are supplying to solar farms today. And railways, we have done 100% indigenization. And now we are working on electrical vehicle. Electrical vehicle propulsion system, no company is available, including Tata, Ashok Leyland, Mahindra, these companies. They made the vehicles, but the propulsion system, the powertrain is not done in India. It is imported. We are the only people who have done the powertrain in India to support all our automotive segment. And the other one is the defense. Defense also we are working for the ship propulsion and submarine propulsion. Now this company is a very good company, technology company in the country. And with this technology, we brought this canal automation technology to India to serve farmers. That's the main objective. The advantage of this, our product is mainly for the farmer benefit. And the other important point, this company is not just in India, not in Hyderabad. We are globally present today. The MNC, it's Indian originated MNC. It is not just a MNC came from other country to India. We are the people, we have built the technology in other countries like Italy, Spain, Brazil, New York, and Texas. Now we are supplying to other countries also. This is about MEDA. And today, MEDA turnover is like something like 2,500 crores we do with our own technology. And we have a very good presence in the technology area. Because of this canal automation technology, we brought this technology into India with the support from Rubicon. This is what about the canal automation. And I just wanted to take your feedback. If I need any questions or any slide, I can go back.
Thank you, sir. Thank you for your wonderful, informative and very practical this on canal automation. Really, we are very happy with your lecture, and I hope everybody has enjoyed. Anybody has any questions, please? Okay, if nobody has any questions, I request our joint honorary secretary, and today as our secretary is not contact is has an internet problem. So I request Dr. Sita Rambabu Garu to kindly propose vote of thanks.
Sir, thank you very much, sir. It's my privilege to read the vote of thanks on the occasion of R.L. Raju 9th Endowment Lecture on Canal Automation. Respected keynote speaker, Sri Satya N. Jiddu, Director General, Director Manager for Designs R&D, MEDA Servo Drives Private Limited, the Chairman of the Institute of Engineers, Brahma Reddy Garu, Chairman IEI, then Dr. I. Sachanan Raj Garu, a council member, all IEI and council members, convener of the event, past presidents, past vice presidents, council members of IEI, past chairman, past honorary secretaries, committee members and corporate members of the Institute of Engineers of Telangana State Center, family members of Engineer R.L. Raju Garu, budding engineers, ladies and gentlemen, good evening to all. It gives me immense pleasure to perform the present duty of proposing the vote of thanks on behalf of the Telangana State Center of the Institute of Engineers India and on my own behalf. I convey our sincere and profound thanks to the keynote speaker, Sri Satya N. Jeddu Garu, General Manager, Design, R&D, MEDA, Servo Drives Private Limited, and past Chairman IEI TSC, addressed the gathering and delivered the lectures. I also thank the dignitaries, the past presidents of IEI, past chairman of IEI, Telangana State Center, past honorary secretaries of the Telangana State Center of Institute of Engineers, council members, committee members, and corporate members, and others who made it convenient to attend the event. I also thank the representatives of the media for unstinted support to cover the proceedings of the event. Thanks to one and all are requested to raise for the national anthem. Thank you very much, sir.